In this video, I'm going to derive the Mohr circle for you. I've actually shown you the Mohr circle now for several different problems without really explaining to you. We derived the area moment of inertia transformation equations, and we actually used the 2 theta form of those equations to derive the Mohr circle. So I'll derive it and then explain it to you what it is, how we set it up, how we use it, how we plot the x face and the y face on the circle, and how we find Imax and Imin from the circle. And so then we'll work a bunch of examples using Mohr circle. So this is a derivation of Mohr circle. So earlier, we derived the 2 theta forms of the area moment of inertia transformation equations. And basically, if we are given for an area, Ix, Iy, and Ixy, then we seek I about a set of axes that are rotated some theta from X, or from the XY set of axes. Your Hitler book calls it Ix prime, Iy prime, Ix prime, Y prime for the rotated axes. And I'll do that sometimes. I prefer to call this like IU, IV, and IUV at some theta. Either way, you'll see it different ways. So that's what we're looking for. Just remembering these are the equations that we got, the 2 theta forms. We get an IU is equal to I average plus this Ix minus I over 2 cosine 2 theta minus Ixy sine of 2 theta. Also, we had an Ix prime Y prime or an IUV equation. So this is the equation that calculates the product of inertia in that rotated coordinate system. And that was equal to Ixy cosine 2 theta plus Ix minus Iy over 2 sine 2 theta. So those are the guys we're going to use to derive the Mohr circle. Just to remind you, if you think about the equation for a circle, so a circle centered at the origin has the equation x squared plus y squared is equal to r squared. If you have a circle with a general center at some hk, then the equation is x minus h squared plus y minus k squared is equal to r squared. And so that's a general circle located in the xy plane. Finally, Mohr circle is of this form. So Mohr circle is a circle that lies, it's centered on the x-axis. The entire circle is to the right of the vertical axis, some distance h. And so this is the mathematical form of Mohr circle that we're going to end up with. And the horizontal axis is moment of inertia. And so this is like your Ix and Iy and your I average will all plot in this horizontal axis. The vertical axis is going to be product of inertia. It's going to be Ixy. And so Ixy y values will plot vertically. One thing is else to note. So what this circle is this circle is a locus of points of all combinations of moment of inertia and product of inertia at every orientation in the plane. So all of it, for a given area, if you rotate those axes, you're going to calculate a different moment of inertia, and different Ixy. But all of those guys are going to fall on this circle somewhere. The Imax is the far right edge of the circle. And at Imax, you can see that the vertical axis is 0. So in other words, Ixy at the max is 0. And at the far left edge of the circle is Imin. And again, Ixy is 0 at that point there. And so Ixy is 0 at Imax and Imin. So how do we get the circle? So what we're going to do is we're going to take these two equations. And this first equation, I'm going to let this be I average. And I'm going to move it to the left-hand side. And so I have IU minus I average is equal to this guy, and I'll call him capital A, cosine 2 theta minus IXY sine of 2 theta. And so that's a slight modification of this first equation. The second equation for IUV, the product of inertia at that rotated coordinates, is equal to capital A sine 2 theta plus IXY cosine 2 theta. We're going to square both sides of these equations and then add them. So IU minus I average squared plus IUV squared is equal to squaring this is going to give me 3 terms, and squaring this is going to give me 3 terms. So the 3 terms that I get from the square of these guys are A squared cosine squared 2 theta plus IXY squared sine squared 2 theta, and then minus 2A cosine 2 theta sine 2 theta. The 3 terms that I'm going to get from the square of the second equation are A squared sine squared 2 theta plus IXY squared cosine squared 2 theta plus 2A IXY cosine 2 theta sine 2 theta. So I have 6 terms on the right-hand side. I have a minus 2A IXY term. I have a plus 2A IXY term. These guys cancel. These A squared cosine squared plus sine squared is A squared times 1. So this just becomes A squared. And then I have IXY squared and cosine squared plus cosine squared. And so those guys become 1. So what I end up with is IU minus I average squared plus IUV squared is equal to A squared plus IXY squared. But A squared is this IX minus IY over 2 squared plus IXY squared. So think about this for a moment. The right-hand side is in terms of IX, IY, and IXY. So these guys were given at the beginning of my problem. So they're not changing. These are constants. And if you look at this, this looks like Pythagorean theorem. It looks like a horizontal distance, and it looks like a y distance. And this guy squared is plus this guy squared is an r squared. So this looks like a triangle, which it is. And again, this term gives us a radius for a circle. And this is a fixed length or a fixed size, again, because IX, IY are fixed. The same circle, you can let this line rotate to some IU, IV, IUV position at some different angle. And it's going to have the same radius, the same I average, and the same circle as this guy. So this equation suggests a circle with I average at the middle, a radius that's equal to this guy. So to set up Mohr circle. So if you have a given IX, a given IY, and a given IXY, you can calculate an I average. You can calculate a radius. And we've done this before, but I just now showed you where it came from. We calculate a radius. And so we draw the circle. So this is how I do it. I draw the circle first. Then I draw the horizontal axis through the circle. Then I put a dot in the middle of the circle. Then I put the vertical axis. Remember, the entire circle always lies to the right of the vertical axis. And so the vertical axis stays to the left somewhere. Remember, in the horizontal direction, this is moment of inertia. And in the vertical direction, this is product of inertia. Remember, for moment of inertia, we've said it is always positive. That's why the entire circle rests on the right-hand side of the vertical axis. We've also said the product of inertia, IXY, can be positive, negative, or zero. And you can see that from this picture. The top half of the circle has positive values of IXY. The bottom half of the circle has negative values of IXY. And at Imax and Imin, you have zero values of IXY. So again, this circle, so keep in mind, this is a Cartesian coordinate system where the horizontal coordinate is area moment of inertia, and the vertical coordinate is product of inertia, or IXY. So as we rotate our axis systems, the various combinations. So each orientation will have its own IX, or its own IU, its own IV, and its own IXY, or IUV. And so as you walk around this circle, you've got combinations of IU and IUV, the product of inertia, and they're all going to fall on the circle somewhere. And so the circle is the locus of all combinations of those guys as you walk around the circle. So in other words, your IX is somewhere on the circle, your IY is somewhere on the circle, your Imax and Imin are somewhere on the circle. One more subtle feature is that, remember, theta was a single theta here at which we located our rotated axis system. But because we used the two theta equations and squared them in order to get more circle, so you still have all these two theta forms. The theta on your original area corresponds to 2 theta on more circle. So whenever we plot IX, IY will actually be 180 degrees from IX. And so IY will plot over here. So 2 theta on more circle corresponds to theta on your original area. It's just a result of the math. So how do we find theta P from our x-axis to the Imax or the Imin? So we basically said that IXY is 0 at our Imax or our Imin. So what we can do is we can actually take the IUV equation, set him equal to 0, and solve for theta P, to solve for the angle at which this guy is 0. If you do that, we take this equation, set him equal to 0. Once you set him equal to 0, you can solve for tangent of 2 theta P, and that's equal to negative IXY divided by IX minus IY over 2. And then theta P is equal to 1/2 inverse tangent of negative XY divided by IX minus IY over 2. And so once you plot your IX and your IXY, that point can be in the first quadrant of the circle. That point can be in the second quadrant of the circle. That point can be in the third quadrant of the circle, or that point can be in the fourth quadrant of the circle. This equation will always give you the nearest principal to the IX face. And so if your IX is in quadrant 1, this will return a negative number, which basically takes you down to I max. If the X face plots in quadrant 2, this equation will report a positive number that will take you down to I'm in. Remember, positive is always counterclockwise and negative is clockwise. If our X face plots in the lower in quadrant 3 of the circle, then the theta p will be negative, and he'll take us up to I'm in. And finally, if our X face plots down in the 4th quadrant, then this equation will take us positive up to I max, which is the nearest. So this guy will always give you the angle from our plotted X face to the nearest principal, either the nearest, whether it's I max or whether it's I min. And that number will be positive if we're going counterclockwise. It will be negative if we're going clockwise. One of the things I want to point out to you while we have this circle up, I mentioned that IX and IY plot on opposite sides of the circle. If you drop a vertical down from IX, and if you drop a vertical down from IY, the distance between these guys is IX minus IY. The half of that distance is the bottom leg of this triangle. And so the bottom leg of this triangle is IX minus IY over 2. And then the vertical leg of this triangle is IXY. Because again, we're plotting this point, which is the IX on the horizontal axis and IXY on the vertical. So that forms a triangle. And so basically, again, so IX minus IY over 2 squared plus IXY squared gives you R squared. So whenever you see these terms, realize these are terms in that triangle that is set up in the plot of Mohr circle. Furthermore, if you look at the angle from this IX line to the nearest principal is this angle. That angle is 2 theta p. The tangent of 2 theta p is equal to IXY divided by IX minus IY over 2. If I scroll down here, I showed you this, so 2 theta p, tangent of 2 theta p is equal to IXY divided by IX minus IY over 2. And this is actually negative because we're actually going clockwise on the circle from the X to the theta p. So this turns out to be a negative. But so we derive this equation from setting that IUV equation equal to 0. We got this. But you can also get this, the same equation, from understanding Mohr circle. Understanding that this radius, IXY, and IX minus IY over 2 form a triangle. And again, the angle here is 2 theta p. So remember, theta p on the original shape is 2 theta p on the Mohr circle. So whenever you see IX minus IY, that looks like a confusing term, but just visualize it's this distance on the circle. Again, because this is IX, this is IY, those guys divided by 2 is the base of that triangle. I told you that Mohr circle is the locus of combination of points. I actually have a different Excel spreadsheet that's in your OneDrive or on the course website where you can input an IX, an IY, and an IXY for a given area. You can put in an angle, and it will plot. The blue circle is the IX face. And so in this case, the IX is positive and the IY is IXY is positive. So remember, the horizontal axis is area moment or inertia. The vertical axis is IXY. Our IY plots as 5 and -2. So it's 80 degrees apart from X. And that's the green circle. We can actually animate this guy. And so we can actually step this circle. I'm going to reset it. So we can actually step this. And the step changes this angle. And so this is 5 degrees on the element, which is 10 degrees on Mohr circle. I can step again. This goes to 10 and it plots there. Step again. This goes to 15. Step 20, 25, 30. And we're almost to 30 some odd degrees. The theta P is actually 32 degrees from our original X face to the nearest I min or I max, and that happens to be at I min, is where that goes. You can keep stepping. But my point is, along this circle, again, are all the combinations of X and Y and IXY at all of the different orientations. You can actually animate the circle. You can actually just animate it. And it's basically stepping on theta and just walking you around the circle. And so there's the same thing as taking that original area and just stepping as you go and calculating the new IU, IV, and product of inertia as you step around the circle. Pretty cool, kind of fun. So play with it. So this is available on OneDrive. It's available on the website. When you download it, it's possible that your computer may not like it. And so save it on your computer and go right click on the file name, go to properties, and you might have to set it as safe to open. That might be a possibility.